Okay, so since we've talked a little bit about recursive formulas, we're going to talk about explicit formulas now. Okay, so an explicit formula is a rule in which the nth term is defined as a function of n. So in this case, previous terms are unnecessary. So previous terms are unnecessary. I forgot how to spell unnecessary for a second. Okay, so we're not looking at the previous terms. We're strictly looking at n. Okay, we're just going to write a formula, well, we will later, to help us figure out the next three terms of a sequence, okay? So here's some examples of using a formula. Find the first 5 terms of each sequence. So in number 7, like I said, we'll do the odds here, we'll do the evens in class. We want to figure out the first 5 terms. So to figure out A1, or A sub 1, gosh, I broke my own rule already. A sub 1, all we have to do is plug in 1. So 1 minus 3 is negative 2. 7 times negative 2 is negative 14. Okay? To figure out the term you're looking for, you just plug in the term number. So if I want A sub 2, the second term, I plug in 2. 2 minus 3 is negative 1 times 7 is negative 7. Okay? On and on. A sub 3, plug in 3. 3 minus 3 is 0. Anything times 0 is 0. Okay? We need 4 now. A sub 4. 4 minus 3 is 1. 1 times 7 is 7. Okay? And then 5. 5 minus 3 is 2. 2 times 7 is 14. Okay? So that's it. You just plug in the number that you're looking for. So for number 9, if I want A sub 1, I plug in 1. Well, 1 squared is 1. Negative 4 times 1 is negative 4. Okay? If I want A sub 2, plug in 2. 2 squared is 4. Negative 4 times 4 is negative 16. Okay? If I want A sub 3, 3 squared is 9. 9 times negative 4 is negative 36. Okay? 4 squared is 16. Negative 4 times 16, which is still negative 4 cubed, is negative 64. And then finally 5 squared is 25 times negative 4 is negative 100. Okay, so it's not too bad. All right, so number 11, they throw in n minus 1, it's still the same thing. If I want A sub 1, I'm going to plug in 1. 1 minus 1 is 0. Anything to the 0 power is 1. Okay. Now I plug in 2. 2 minus 1 is 1. Negative 2 to the first power is negative 2. Okay. 3 minus 1 is 2. Negative 2 squared is a positive 4. Now I plug in 4. 4 minus 1 is 3. Negative 2 cubed is negative 8. Okay. Now 5 minus 1 is 4. Negative 2 to the 4th power, well, what's 4 squared? That's 16. Okay? So using an explicit formula is actually pretty easy. Okay? So let's write an explicit formula for each sequence and then give the next 3 terms. So again, make a little star. Can't see that. Let me zoom out so you can. We're going to make a table again. Okay, that's the easiest way to figure out a formula is to make a table for these ones. Okay, for both of them. So we'll come over here and make a little table. Actually, we'll do it right here. Okay, so we have our term, and then our actual term. So our term number, and then our actual term. So we have 1, 2, 3, 4, 5 terms that they give us. They give us negative 7, negative 9, negative 11, negative 13, and negative 15. So we're going to figure out the differences first of all. And if we get a common difference, then great. That's really, really, really easy. So this one goes down by 2, down by 2, down by 2, down by 2. We have a common difference. Hooray! So that means our a sub n is we're going to take -2 times our term number, okay? But I want to get from -2 times 1 is -2. How do I get from -2 to -7? I have to subtract 5. Let's test it with another one. -2 times -9. Oh, I'm sorry, I'm doing this wrong. -2 times 2 is -4. How do I get from -4 to -9? Subtract 5. So yeah, it works. Okay, so now I need to figure out the 6th, 7th, and 8th term since we only go up to 5. So -2 times 6 is -12. -12 times, or -5 is -17. We know they're going down by 2 each time, right? So -17, -19, -21. Okay, so that's all the information they wanted on that one. And again, I'll go through this in class if we need to. I'll try and go a little bit slower, but this stuff is pretty easy. Okay, so again, we'll make a table here. I know this is a little small, but that's okay. So they give us 1, 2, 3, 4, 5 numbers. And we're going to put these in decimal form just because it's going to be a little bit easier to put them in decimal form. So we go 2, half of 5 is 2.5, 3, half of 7 is 3.5, 4. So clearly we can see a pattern already, right? They're going up by half each time. Okay, I forgot the little plus here. So that tells me that our common difference is 0.5, which means I'm going to multiply my term number times 0.5. Okay, and then I need to figure out how to get from here to the next, or to the actual term number. So if I multiply this by 1, 0.5 times 1 is 0.5. How do I get from 0.5 to 2? Well, I have to add 1.5, right? So let's just see if we can do this for the next ones. If I want the second term, 0.5 times 2 is 1, because half of 1 is 2, or sorry, half of 2 is 1. Gosh, I can't talk today. Okay, and how do I get from 2, or 1 to 2.5? I have to add 1.5. Okay, let's try it again. 3.5 times 3 is 1.5. To get to 3, I have to add another 1.5. So it works. Okay, there's an easier way to write this too if you don't want to deal with decimals. Get rid of them by multiplying the whole thing, or nah, don't worry about it. We'll just use decimals. It's fine. So I need the next one. So I know they're going up by 0.5, right? So I know my next 3 terms are going to be 4.5, 5, and 5.5 because they're going up by 0.5 at each time. Okay? So that's it for sequences. In concept 2, we'll talk about series. In class, we'll go through the evens. If you have any questions, let me know. That's it for concept number 1.